Hello guys, welcome back to our channel. So today we are starting with another chapter of MHT-CET 12th formula marathon of physics, that is oscillation. Till now we have completed 10th thermodynamics, 11th, 12th max also we have completed. So you can go and watch that series as well. So now play. Before starting, please subscribe our channel, hit the bell icon and do comment. Let's begin with oscillation. Restoring force F is equals to minus kx, where k is constant or force constant, x is displacement. Acceleration is a force upon m minus km, okay, minus k upon m into x. The differential equation of linear SHM is, it is d square x divided by dt square plus k by m into x is equals to 0. So here plus omega square k by m is an omega square is equals to 0, or it is d square x divided by dt square is equals to minus omega square x. This will be important. So acceleration is equals to minus omega square x, and from this only we get this omega is minus k by m x1. This thing also we get from here. Velocity of a particle performing linear SHM is v is equals to plus minus omega root of a square minus x square. Displacement x of a particle performing linear SHM. Linear SHM is x is equal to a sin omega t plus 5. Case 1, if particle starts SHM from mean position, x is equals to 0 and t is also equivalent to 0. Plus minus a sin omega t will be our x value. And now, if particle starts SHM from extreme position, that is x is equals to plus minus a at t is equals to 0. So it will be x is equals to plus minus a cos omega t. Now, expression of displacement x, velocity v and acceleration a at time t. So x is equals to a sine omega t plus phi. This is there. So v is equals to d by dx is equals to a omega cos omega t, a omega cos omega t plus 5. A is equals to dv by dt minus a omega square sin omega t plus 5. Now, velocity of a particle at mean position and extreme position. So, x is equals to 0, then v max is equal to plus minus a omega. Extreme position, x is equals to plus minus a, then v minimum is equals to 0. Now, at mean position, x is equals to 0, so that acceleration is minimum. Acceleration will be minimum. At extreme position, x is equals to plus minus a, so that acceleration is maximum. So, a max is equals to minus plus omega square a. This will be our answer. So, period of SHM t is equals to 2 pi root of m by k. Frequency n is equals to 1 by t, which is omega by 2 pi, and if we put up this value, we get n is equals to 1 by 2 pi root of k by m. This is we get projection of displacement y is equals to r sin omega t plus y. Projection of velocity v y is equals to r omega cos theta r omega cos omega t plus phi. Projection of acceleration a y is minus r into omega square sin theta minus r into omega square sin omega t plus phi. A y is equals to minus omega into y. Now, graphical representation of SHM. Particle executing SHM starting from mean position towards phi is equals to 0. Displacement x is equal to a sin omega t, velocity v is equal to a omega cos omega t, acceleration minus a omega. So if we put up this value, we get t is equals to 0, and this is the table. You can use this and you can get to know about what points, which values are there. It will be easier for you to get the answers. Put up this value and get your answers. This table is very useful. If you want, you can take screenshot of this as well. A graphical representation of SHM, particle performing SHM starting from positive. Extreme value phi is equal to phi. So displacement x is equal to a sin omega t plus pi by 2. So x is equal to a cos omega t. Velocity v is equal to dx by dt. So v is equal to minus a omega sin omega t. Acceleration minus a omega square cos omega t. Equation of SHM, x is equals to r sin omega t plus delta Resultant amplitude is R is equals to root of A1 square, A2 square, 2 times of A1, A2 cos phi minus phi 2. This will be like this. Cos phi 1 minus phi 2. Initial phase of the resultant. Delta is equal to tan inverse of A1 sin phi plus A2 sin phi, A1 cos phi plus A2 cos phi. Special cases, if two SHMs are in phase, phi 1 minus is equal to 0. So cos phi 1. So A1 is equal to A2 is equal to, we get R is equal to 2 times of A. If two SHMs are 90 degree out of phase, so phi 1 90 degree, cos phi 0. So R is equal to root 2A. If two SHMs are 180 degree out of phase, phi 1 minus phi 2 180 degree, cos phi minus 1, R is equal to 0. This we get. The kinetic energy Ek is equals to half of m omega square a square minus x square. So here we get half of k a square minus x square. Kinetic energy of displacement at time t. So Ek is equals to half of mv square, and we can get half m like half of m a square omega square cos omega t plus phi. So here by solving further, half of Ka square cos square omega t plus phi. This we will get. Potential energy of the particles of displacement x. Ep is equals to half of K square is equals to half of Ka square sin omega t plus phi. Ep is equals to half m omega square x square. Total energy of particle and sum of its kinetic energy potential energy is equals to half of m omega square a square. Solving further, here we get half of k square. So this is half of m v max the whole square. Now e is equals to half 2 pi n square. Omega is equals to 2 pi n. Solving further, e we get 2 pi square m a square by t. You can check these steps as well, but formula you can use this one. Special case, let mean position x is equal to 0 and velocity is maximum. E is equals to e kx max into half of m omega square a square, and potential and EP minimum is equal to 0. EP, the velocity of particle is 0 at x is equal to plus 1. So EP is equals to, yeah, here EP max half of m omega square. So kinetic energy EK, E minimum is equals to 0. If kinetic energy is equals to potential energy, so we get x value is equals to plus minus a by root 2. At x equals to a by 2, potential energy is equals to E by 4. Putting in this and we can get this answer. Time period T is equals to 2 pi root of Lg. N is equals to 1 by T. N is equals to 1 by 2 pi root of G by L. Pendulum T is equals to 2 pi root of Lg. Length of second pendulum L. S is equals to G upon pi square. Length of second pendulum G is equals to G by pi square. L, okay, L is equal to G by pi square. C is tau is equals to C minus L. C is constant of proportionality. Theta is angular displacement. Differential equation for angular SHM is equals to d square theta divided by dt square plus c theta is equals to 0. Angular acceleration alpha is equals to d square theta by dt is equals to minus c theta divided by I. This typo error. And 29 tau is equals to mu d theta, where t is torque, mu is magnetic dipole moment, b is uniform magnetic field, theta is angular displacement. Tau, this we studied further on the slide. Tau is equals to I alpha, I is moment of inertia of power magnet, alpha is angular acceleration, so alpha is equals to minus mu b I by theta, or t is equals to 2 pi root of I by mu d. Now, damped oscillation m is equals to d square x square dt will be b into dx by dt plus kx is equals to 0. And this where a is where m is amplitude of damped harmonic oscillation. This is what we get. X is equals to angular frequency omega dash is equals to root of k m minus b 2 times of m the whole square. I'll write of x here. X is equals to a e raised to minus pt divided by 2m cos omega dash t plus 5. This is what we get of damped oscillation formula. Period of oscillation t is equals to 2 pi by omega dash. So this we get 2 pi by omega dash divided by root of k by m minus b by 2m the whole square. Pre-oscillation n is equals to 1 by 2 pi root of g by n. So by this, we have completed our oscillation chapter. I hope you have understand it. If you have any doubts, please comment below. Please subscribe this channel, hit the bell icon and do comment. Thank you for watching this video.